In the hushed, final years of the Cold War, a chilling development took root deep within the labyrinthine bureaucracy of the Pentagon. It was a project shrouded in an almost impenetrable veil of secrecy, a quiet authorization that greenlit the creation of a device so profoundly destructive, so inherently unpredictable in its operational reality, that even the brilliant minds who conceived it wrestled with a terrifying moral and strategic dilemma: should this weapon be allowed to exist at all? The very nature of the project defied the dramatic, familiar landscape of Cold War arms racing. It wasn't the next generation of an intercontinental ballistic missile, gleaming and terrifying in its silo. It wasn't an advanced stealth bomber, whispering across the radar screens of the enemy. It was not even a classified nuclear project, the kind of behemoth of physics and engineering typically buried beneath tons of concrete in some remote, forgotten corner of the American West. It was something far stranger, a concept that belonged more to the realm of science fiction than to the gritty, conventional doctrine of land warfare. This was an experimental weapon designed not merely to destroy, but to erase entire armored columns, hundreds of tanks, armored personnel carriers, and support vehicles, without the use of a single, conventional explosive. No shrapnel, no concussive blast, no flash of incendiary fire. It was destruction by invisible hand. And for almost 4 decades, a period spanning the collapse of the Soviet Union, the rise of the digital age, and countless revisions of military history, the powerful institution that had birthed it, the Pentagon itself, insisted with an almost chilling uniformity that it never happened. The documents were missing, the personnel scattered, and the very concept was dismissed as a technical impossibility, a phantom project that existed only in the fevered imaginations of disgruntled former engineers or speculative intelligence analysts. But the ghost of the project, codenamed Zeus's Wrath by a particularly melodramatic junior officer, lingered. It was a weapon designed to solve a problem that seemed utterly insoluble, a strategic nightmare woven into the very fabric of Cold War doctrine. To understand the gravity of its development, one must first look back to the moment the conventional instruments of war, even the apocalyptic power of nuclear weapons, proved insufficient. The geopolitical chessboard of the late 1970s was a study in precarious, hair-trigger tension. The Cold War, far from cooling, had entered a dangerous phase of technological escalation, underscored by the ever-present threat of conventional conflict in Europe spilling over into global conflagration. At the heart of this fear was a narrow, historical corridor of land in West Germany, the Fulda Gap. This unassuming stretch of rolling hills and lowlands, roughly 100 kilometers east of Frankfurt, was considered by both NATO and the Warsaw Pact to be the single most likely invasion route for a massive Soviet thrust into Western Europe. U.S. intelligence assessments were dire, bordering on apocalyptic. They had concluded that a Soviet tank rush through the Fulda Gap was not a question of if it would happen, but when. The Soviet Union's armored doctrine was terrifying in its simplicity and scale, overwhelming force, moving at lightning speed. Waves upon waves of T-72 and T-80 tanks, supported by mechanized infantry, designed to smash through NATO's thinly spread forward defenses and achieve the strategic goal of reaching the Rhine River in a matter of days. NATO's existing response options were all variations on a theme of catastrophic destruction. Tactical nuclear landmines (ADM), these were essentially small, prepositioned nuclear devices designed to be detonated in the gap to create a radioactive, impassable wasteland. They were, however, deemed too destructive. Their blast radius and subsequent fallout would contaminate massive swaths of sovereign German territory, the very territory NATO was sworn to defend. Winning the battle would mean losing the land. Tactical nukes, artillery, short-range missiles, the use of tactical nuclear weapons, W-48 artillery shells or Lance missile warheads, carried an even greater political and existential risk. Any escalation to nuclear use, no matter how limited or tactical, was a roll of the dice with Armageddon. It was politically impossible for NATO governments to authorize their use without triggering the most profound crisis of legitimacy and global horror. The cost of stopping the tanks would be the destruction of the world. The Army, therefore, articulated a desperate, almost paradoxical need. They required a weapon that could stop thousands of tanks dead in their tracks, neutralize the vast mechanized engine of the Warsaw Pact, yet do so without creating a massive crater, without leaving a radioactive signature, and crucially, without harming buildings or civilians in the immediate vicinity. They wanted a precise, surgical, non-nuclear coup de grace for the internal combustion engine. It was this impossible mandate that landed on the desks of a small, obscure, and deeply unconventional group of researchers backed by DARPA, the Defense Advanced Research Projects Agency. They were given the green light to propose something unusual, something that scoffed at the conventions of kinetic and explosive warfare. Their solution: the electromagnetic weapon. They theorized the deployment of a system, eventually dubbed the silent hammer, in classified memos, that would release a short-lived, precisely directed burst of electromagnetic energy. This wasn't the slow, pervasive radiation of a nuclear blast, but a hyper-focused pulse, a momentary spike of power strong enough to overload, burn out, or simply confuse the delicate electronic circuitry and ignition systems of every mechanized vehicle in a kilometer-wide radius. It would be a tank killer that left no crater. It would stop the engines, scramble the complex navigation systems, fry the radios and fire control computers. The tanks would simply grind to a halt, their crews stranded, confused, and powerless, surrounded by non-functional metallic behemoths. The infantry could then mop up the now inert force. The promise was simple and breathtaking: destruction without residue. A perfectly clean kill. The DARPA project was initially overseen by a man known only by the cryptic internal codename, the Bishop, Dr. Elias Thorne. Thorne was a theoretical physicist with a background spanning particle accelerators and high-altitude atmospheric testing, a man who spoke in complex equations and wore the perpetual exhaustion of someone who dealt daily with forces that could alter continental power balances. His team was equally eclectic, a mix of electrical engineers who specialized in magnetohydrodynamics, computer scientists obsessed with circuit failure analysis, and a handful of former Army armor officers who provided the necessary operational grounding. The core challenge was translating a known phenomenon, the electromagnetic pulse (EMP) generated by a nuclear detonation, into a localized, non-nuclear weapon. The conventional EMP is a terrifying side effect of an atmospheric nuclear explosion. The gamma rays from the blast strike air molecules, creating high-energy electrons that are then accelerated and guided by the Earth's magnetic field. This process generates an enormous, very fast pulse of electromagnetic energy that spreads out over a huge area, capable of wiping out electrical grids and all unshielded electronics. But it required a nuclear explosion, the very thing the Army was trying to avoid. Thorne's team sought to achieve the same result via a different, elegant, and non-apocalyptic route. They focused on a concept called the Explosively Pumped Flux Compression Generator (EPFCG). The EPFCG principle, the science of the silent hammer. Imagine a simple, cylindrical coil of copper wire. Now, imagine running an initial, powerful current through that coil, generating an intense magnetic field within it. The key is to then rapidly compress that magnetic field. Step 1. The seed field. A small conventional explosive charge is used to power a capacitor bank, creating the initial, seed current, in the copper coil. Step 2. The compression. A main, high explosive charge, non-nuclear, conventional TNT or composition C is detonated inside the coil. As the explosion expands, it physically deforms and collapses the inner wall of the coil, forcing the moving magnetic flux into a smaller and smaller volume. Step 3. Flux compression. Since magnetic flux is conserved, forcing it into a tiny space causes the magnetic field density to skyrocket. This translates into an immense, momentary rise in the output current. The coil acts like a magnetic amplifier, taking a small initial electrical current and transforming the explosive energy into a devastating pulse of electricity. The critical difference was the pulse duration. A nuclear EMP pulse lasts for nanoseconds. The EPFCG pulse, while still measured in microseconds, was longer, meaning it was more effective at injecting the current into the larger, unshielded wires and components of a tank's engine and fire control systems, rather than just damaging the smaller integrated circuits. It was a sledgehammer, not a scalpel, but a sledgehammer made of pure, raw electricity. In the controlled environment of the lab, with the prototypes securely housed in deep underground bunkers, the results were astonishing. A single pulse could instantly melt the alternator coils of a standard truck engine, seize the electronic fuel injection systems of a small car, and permanently corrupt the magnetic memory storage of a complex missile guidance unit. The scientists were ecstatic. The Army was cautiously optimistic. The technical challenge was solved. But the moment the silent hammer left the sterile, controlled environment of the testing range and entered the realm of operational reality, the true, terrifying complexity of the weapon began to surface. The testing was moved to a remote, high-desert facility in Nevada, far from any major civilian infrastructure. The goal was to miniaturize the generator and integrate it into a deployable package, a large landmine, disguised as a common culvert or rock formation, that could be rapidly scattered by aircraft or artillery in the path of an advancing enemy column. The project name was formally changed from Zeus's Wrath, too mythological, and Silent Hammer, too obvious, to the innocuous, almost dull, System 712, Non-Kinetic Area Denial System. The first large-scale field test involved a captured Soviet T-62 tank and a series of dummy armored personnel carriers positioned at varying distances from the buried System 712 unit. Test Day 1A flawed success. When the detonation command was given, the earth trembled with the muffled thud of the conventional explosive charge. There was no mushroom cloud, no large fireball, only a momentary shimmer in the air, a sign of the invisible pulse of energy rushing outward. The T-62, the tank's engine, running at idle, instantly sputtered and died. When the test crew tried to restart it, the ignition was dead. The radios were silent, the targeting computer screen blank. Total mission kill. The APCs, the surrounding APCs were similarly incapacitated. The system was a success. But the post-test analysis revealed the first insidious problems, the unpredictable ghost of the electromagnetic wave. Inverse square law and containment. The pulse did not follow a neat, 360-degree perfect circle. Due to minute variations in the coil's collapse, the presence of subterranean moisture, and even the natural magnetic anomalies in the Earth, the pulse strength was highly directional and variable. A tank 800 meters to the north might be completely inert, while a tank 500 meters to the northeast, inexplicably, might only suffer a momentary power flicker before restarting. The kill radius was unreliable. Collateral electronic damage. More alarmingly, the pulse was powerful enough to induce currents in all metallic conductors in the area. A small, unshielded communications repeater antenna positioned 1.5 kilometers away, well outside the supposed kill zone, was found to have been completely fried. While the system was non-nuclear and non-radioactive, it was emphatically not non-destructive. Any civilian power lines, unshielded radio equipment, or delicate sensor arrays placed downrange could be instantly and permanently damaged. In a densely populated European operational theater, this was a massive complication. The human factor. The final, and most concerning, discovery was the effect on the unshielded test personnel outside the target zone. While the pulse was too brief to cause conventional electrical shock, several observers reported a momentary, deep ache in their bones and an unsettling feeling of disorientation, akin to a flash of bright light directly in the retina. The energy levels, while non-lethal, were clearly interacting with the human nervous system in an unknown, unsettling way. The long-term effects were entirely unstudied. The designers had created a weapon that could be fired, but could not be entirely controlled. It was a strategic asset, but a tactical and political liability. It was a force of nature that the Pentagon had unleashed, and now, they had to confront the terrible reality of a weapon that might damage its own side as much as the enemy's. Despite the terrifying technical uncertainties, the U.S. Army leadership refused to abandon System 700. The strategic temptation was simply too great, the threat of the Soviet juggernaut too immediate. The need for a clean kill mechanism outweighed the fear of the unpredictable ghost. General Matthew L. Vance, the then commander of NATO's Central Army Group, summed up the dilemma in a classified briefing memo. We can risk the loss of a few satellite communication arrays and a few headaches for our troops, or we can face the total collapse of Western Europe. The Soviet conventional threat is not a technical problem, it is an existential one. System 712 is the only option that is not either mutually assured destruction or certain defeat. The focus shifted from making the weapon perfectly reliable to making it deployable and deniable. The deniability doctrine. If the pulse was invisible, silent, and left no traditional forensic evidence, it was untraceable. If NATO forces deployed System 712 in a conflict, and the Soviet advance suddenly ground to a halt, the Russians would have no concrete evidence of what happened. Was it a massive, simultaneous electronic failure? A flaw in their own systems? An act of sabotage? This deniability was a core requirement for a weapon that operated so close to the nuclear threshold. It offered a crucial step in the escalation ladder, a way to inflict a strategic-level defeat without triggering a nuclear counter-response or a conventional war that demanded massive troop movements. Miniaturization and Deployment Project, Stonewall. The engineers were ordered to stop chasing perfect containment and focus on robust deployment. The final design was a massive, drum-shaped device, encased in a hardened fiberglass shell and designed to be buried at depth. It was too heavy for a simple artillery shell but perfect for helicopter drop. The Black Hawk variant, a specialized Black Hawk helicopter unit, was secretly trained to drop the disguised devices during high-speed, low-altitude runs into the Fulda Gap at night. Artillery-delivered mines. The cluster variant, a smaller, less powerful cluster munition version, was developed, containing multiple smaller EPFCG coils, designed to be fired over an area and detonate in sequence, creating a massive, overlapping pulse field. This version, however, was later rejected due to the extreme difficulty in coordinating the sequential detonations. The most potent version, the large, buried System 712, remained the primary focus. By the mid-1980s, an elite, highly compartmentalized unit of the U.S. Army Corps of Engineers was fully trained and on permanent alert. Their mission was simple. If the balloon went up, they were to deploy the Stonewall, the array of buried electromagnetic mines, across the most vital choke points of the Fulda Gap. System 712 had moved from a theoretical possibility to an operational reality. It was poised to be the decisive, silent weapon of the European theater, a ghost in the machine of modern warfare. But the final, most consequential chapter of the Silent Hammer story would be written not on the battlefields of Europe, but in the sterile, air-conditioned isolation of the Pentagon's deepest archives. As the 1980s progressed, the Cold War began to show the first hairline fractures of its coming collapse. Mikhail Gorbachev's rise in the Soviet Union signaled a period of glasnost and perestroika, openness and restructuring, that, while fragile, began to ease the apocalyptic pressure on the Fulda Gap. This political thaw gave the scientists and strategic planners a crucial window for reflection, and it was in this moment of lessened tension that the moral and existential objections to System 712 finally broke through the wall of operational necessity. The leadership of the project, Drive, Thorne and his immediate circle, were the first to raise the alarm. They had built the weapon out of necessity. They now realized its existence created a dangerous new precedent. The proliferation nightmare. Thorne's primary objection was not about the collateral damage to NATO's own electronics, but the chilling simplicity of the core technology. The technology of the EPFCG is, at its heart, an amplifier, Thorne wrote in his final project assessment. It takes a small amount of explosive energy and converts it into a terrifying amount of electrical energy. There is no scientific firewall against proliferation. Any nation with a reasonable grasp of conventional high explosives and basic electronics can, and will, replicate a version of this system. Unlike nuclear weapons, which require immense financial outlay, complex enrichment facilities, and highly specialized materials, fissile isotopes and EPFCG could be built by a small team of technically proficient individuals in a large garage. System 712 was not just an ultimate weapon for NATO. It was the blueprint for an electronic weapon of mass disruption for every aspiring rogue state or terrorist organization. The doctrine of mutually assured electronic destruction (MAED). If both the US and the Soviets deployed similar systems, a conventional conflict would become instantly chaotic and unwinnable for either side. An early barrage of EPFCGs could render all air defenses, ground communications, power grids, and strategic command centers on both sides totally inert, effectively blinding the superpowers. This lack of situational awareness dramatically increased the chance of a hair-trigger escalation to full nuclear war, as crippled commanders might default to the only working weapons they had left: non-electronic, silo-based ICBMs. The weapon designed to prevent nuclear war was now seen by its creators as the most likely trigger for it. The internal fight was fierce, a battle waged in highly classified briefing rooms against the hardened generals who still saw a use for their Stonewall. But the tide had turned. The political risk, the fear of proliferation and the certainty of global electronic chaos, had finally eclipsed the military reward. In 1987, a directive signed by the Secretary of Defense, itself classified above top secret, was issued. System 712 was to be terminated. All further research, development, and testing were to cease immediately. All existing operational units were to be decommissioned and destroyed. The specialized Black Hawk unit was disbanded, its personnel reassigned, and their training scrubbed from records. All physical prototypes were to be dismantled and melted down. The raw materials, copper coils, explosive casings, and electronics, were to be repurposed for entirely different projects to mask their origin. The paper trail was to be purged. All project documents, test reports, and blueprints were to be compiled into a single archive, coded with the highest level of restriction, and subsequently, lost, in a fictitious bureaucratic move. This final act was the most telling. The Pentagon did not just decommission the weapon, it sought to erase its memory. They did not want the technology to fall into the wrong hands, nor did they want the history of their dangerous flirtation with a force of invisible destruction to ever become public record. For the next 4 decades, the legend of the electronic tank killer would persist only as a rumor in the intelligence community, a chilling hypothetical in war game scenarios, and a ghost that haunted the careers of the scientists who built it. System 712. The U.S. weapon so dangerous even the Pentagon tried to hide its existence, vanished into the Cold War shadow, becoming an untold story of necessity, terror, and ultimately, the last-minute triumph of caution over annihilation. The ultimate measure of the weapon's danger wasn't its ability to kill tanks, but the fear it instilled in the very people who created it. They knew that in the hands of others, this silence could become the deafening prelude to global chaos. In the meticulously catalogued, but often misleading, archives of the United States military, the project carried no official designation. It exists today only as a series of heavily redacted budget line items and vague, compartmentalized reports discussing advanced non-kinetic energy transfer systems. Officially, it never existed. It was a phantom, a whisper of physics and fear that the military-industrial complex was determined to excise from the historical record. Yet, among the small, intensely focused group of engineers, physicists, and strategic analysts who worked on the concept in the late 1970s and early 1980s, an internal, unofficial codename persisted: Project Starhammer. The name itself speaks volumes, invoking both the celestial, invisible power of the stars and the brutal, mechanical finality of a weapon of war. The objective of Starhammer was rooted in the desperate need for a non-nuclear counter to the overwhelming Soviet conventional threat, particularly the expected armored blitzkrieg through the Fulda Gap. The idea was deceptively simple in concept, horrifying in execution: create a portable, battlefield-ready electromagnetic pulse emitter that didn't require a nuclear detonation. This seemingly straightforward goal was, however, immediately confronted by a towering barrier: physics. The naturally occurring electromagnetic pulse (EMP) generated by a nuclear device detonated high in the atmosphere is a force of staggering, almost unimaginable power. It is created when gamma rays from the explosion collide with air molecules, kicking off cascades of high-energy electrons that are then manipulated by the Earth's magnetic field. This process results in an instantaneous, wide-area pulse that can carry terawatts of power, capable of crippling continental infrastructure. To replicate that sheer, destructive energy, the power necessary to simultaneously fry the engines and electronics of thousands of armored vehicles across a kilometer-wide front, without resorting to the fusion of atoms, would require power levels no conventional generator on Earth could provide. Standard electrical generators, even the most powerful at the time, simply couldn't produce that kind of power instantaneously and in the field. The necessary energy storage banks would be the size of a small skyscraper. The engineers tasked with Starhammer, an eclectic group working out of a highly secured laboratory complex outside Los Alamos, realized they couldn't generate the power in a continuous flow. They had to achieve it through a catastrophic, single-use event. They had to cheat the laws of sustained power generation by concentrating an enormous amount of stored energy into an infinitely brief moment. The solution they devised was both brilliant and terrifying: the exploding capacitor bank and the magnetic flux compression coil. They started with the concept of the explosively pumped flux compression generator (EPFCG), the technology first pioneered in earlier projects. Shutterstock. The principle, as described in their initial classified filings, was to use conventional chemical energy to amplify an existing magnetic field. The capacitor bank, the energy reservoir, the core of the device, was a massive bank of specially designed, hardened capacitors. These weren't the tiny components in a television, they were immense, high-voltage tanks, charged up to millions of volts. This bank served as the primary energy reservoir, the initial seed of power. The self-destructing switch, the microsecond release, to discharge that entire stored energy instantaneously, in a catastrophic microsecond pulse, required a switch that was capable of handling the entire current load without melting. The engineers realized the only perfect switch was one that ceased to exist the moment it was closed. They designed a switching mechanism that used a secondary, smaller explosive charge to physically vaporize the insulator between the capacitor plates, essentially creating a massive, momentary short circuit that dumped the entire load into the coil at the speed of detonation. The flux compression coil, the amplifier, this massive electrical spike was then fed into the center of a precisely wound copper coil. Surrounding this coil was the main, highly stable high explosive charge, non-nuclear, composition B or C. When the switch was closed and the current was flowing, the main charge was detonated. The explosion collapsed the copper coil inward, compressing the magnetic flux field into an infinitesimally small volume, dramatically amplifying the current and converting the chemical energy of the explosion into a colossal, momentary electromagnetic pulse. The result was a single-shot, self-sacrificing device. Every time the weapon fired, it destroyed itself. The act of generating the pulse was the act of annihilation for the machine itself. This single-use design was not a limitation, it was the engineering breakthrough that made Starhammer possible. It meant they didn't need a persistent generator, only a brief, suicidal burst of power. The engineers, led by the intense, socially awkward Dr. Alistair Finch, a man obsessed with Maxwell's equations and the purity of electromagnetic forces, had created a weapon that was transient, violent, and disposable. It was a technological kamikaze, designed to deliver a lethal, invisible punch and then cease to exist, leaving no persistent footprint, save for the wreckage of the enemy's electronics. The theory was sound, but the real-world consequence of unleashing such an untamed force had yet to be understood. The transition from theoretical physics on a blackboard to the brutal reality of an explosion in the field required a location that was secure, remote, and large enough to contain the fallout, not of radiation, but of pure electromagnetic havoc. In the autumn of 1983, the first full-power test of a field-ready Project Starhammer unit was conducted deep within a specially designated, highly restricted area of the Nevada test site. The security around the area was unprecedented, involving a perimeter watch by Special Forces units who had no idea what they were guarding, only that their radios had been specially hardened and they were ordered to stay miles away from the detonation zone. The target array was an eerie, silent graveyard of conventional warfare. It included captured Soviet T-72 main battle tanks, older American M-60 tanks used as control targets, a series of communications vehicles, and, crucially, miles of simulated civilian and military infrastructure, phone lines, power cables, and a small, hardened missile radar dish. Dr. Finch and the testing team watched from a shielded observation bunker 4 miles away. The tension was palpable. They knew the science was sound, but the scale of the energy released was so vast, so outside the realm of conventional testing, that predictions were merely educated guesses. When the command was given, the earth trembled only slightly, a heavy, muffled thump from the buried conventional explosive. There was no visible flash, no mushroom cloud, and only the briefest flicker of a blue-white corona in the air directly above the blast site, the ionization of the air itself, the only visible evidence of the raw electrical violence unleashed. The pulse lasted less than a millionth of a second, a nanosecond blink in time. But the results were immediate and devastating. Armored vehicles lost all power. The engines of the T-72s, running at idle, instantly choked and died. Diagnostic teams later confirmed the engine control units were catastrophically fused, the alternator windings were melted, and every electronic sensor, from the laser rangefinders to the night vision optics, was dead. Total mission kill on all armored vehicles within the kilometer-wide target radius. Radios and radar arrays went dark. The sensitive command and control antennas mounted on the simulated communications vehicles suffered instant, irreparable damage. Wires fused, transistors vaporized. The powerful radar dish, despite being relatively hardened, was effectively blinded, its main receiver module reduced to a useless block of slagged metal. Even underground cables fused silently. This was the most chilling result. Starhammer's pulse was so powerful it induced massive transient currents in the long stretches of copper communication and power cables buried 6 feet beneath the desert floor. The cables, designed to be safe from surface shock, acted like giant antennae, drawing in the electromagnetic wave. The internal wires fused silently, creating a massive blackout in the simulated infrastructure. Observers described the effect with a single, evocative phrase: an invisible hammer. The weapon had performed precisely as designed, delivering destruction with surgical speed and zero conventional collateral damage. The Soviet armored thrust would have stopped, its metal shell becoming nothing more than a giant coffin for its crew, who would be surrounded by functional non-electronics guns, uniforms, food, but utterly stripped of their ability to fight, communicate, or navigate. The technical success was undeniable, but the psychological impact on the project team was profound. The engineers, who had focused so intently on the physics of making the pulse, were now confronted with the terrifying reality of controlling it. The analysis of the fallout revealed the deep, existential flaw in Starhammer. The weapon was simply too effective, too indiscriminate, and fundamentally uncontrollable. The range and overlap problem. The kill radius was enormous, far greater than anticipated, and, critically, the effective range of electronic damage exceeded the anti-tank kill radius. That meant Starhammer could disable command and control vehicles miles away from the target tanks, severely damaging NATO's own supporting infrastructure located on its side of the Fulda Gap. The weapon designed to be precise was, in practice, a giant electronic shotgun. The unshielded threat. The Starhammer device had no way of differentiating between a Soviet T-72 and a NATO M1 Abrams. All electronics, regardless of allegiance, were equally susceptible to the overwhelming power of the pulse. An error in deployment, a shift in the battle lines, or a simple navigational mistake by the delivery team could mean wiping out an entire friendly division's electronic capabilities. The civilian fallout. The fusion of the underground cables at a substantial distance highlighted the nightmare scenario in densely populated Western Europe. If Starhammer was deployed near a major city, it wouldn't cause a physical explosion, but it would silently and instantly take down the electrical grid, the telephone exchanges, the civilian radar, the air traffic control systems, and all vital communication networks across a vast area. The resulting chaos, while non-lethal in the short term, would be a political and logistical catastrophe, a self-inflicted wound worse than a conventional defeat. The terrifying question, articulated by a stunned Dr. Finch in his after-action report, became the central focus of the entire project's review. If this weapon accidentally triggered near-friendly equipment or infrastructure, it could wipe out everything electronic for miles. How do we draw the line on an invisible force? The Starhammer project had crossed a Rubicon. They had developed a weapon that could win the initial battle, but at the potential cost of electronic anarchy across Allied territory. The political and strategic liability suddenly outweighed the military advantage. The initial reaction from the most senior levels of the Pentagon and DARPA was not one of cancellation, but of profound, immediate escalation in secrecy. The strategic value of a weapon that could neutralize thousands of tanks with a non-nuclear flash was too high to simply discard, especially given the ongoing conventional military imbalance in Europe. The response was swift, chilling, and absolute. Funding continued. The development budget for Starhammer was not cut. Instead, it was laundered through a number of unrelated, obscure budget lines, projects focused on materials science and high-energy physics, to make the funding trail vanish. The engineers were ordered to continue working, specifically on mitigating the collateral electronic damage, a futile endeavor, as they discovered. The black hole classification. The existence of Starhammer became classified at the absolute highest levels. The standard, top secret, designation was deemed insufficient. A new, more restrictive level of compartmentalization, unofficially known internally as the black hole classification, was applied. Only a dozen senior officers, 3 politicians, and the core scientific team were granted full access. The knowledge of its existence was seen as a weapon in itself, an ultimate strategic card to hold against the Soviet Union. The purge. The paper trail was aggressively sanitized. All photographic evidence, except for a few key technical diagrams, was destroyed. Personnel not central to the project were transferred and ordered to sign non-disclosure agreements with penalties so severe they amounted to life sentences for minor infractions. The Pentagon's final, desperate act was to try and put the electromagnetic genie back in the bottle, not by stopping the research, but by ensuring that no one outside the inner circle could ever know it existed. Starhammer became a strategic ghost, a terrifying, silent instrument held in reserve, perpetually ready to deploy, yet perpetually feared by its own creators. It was an object lesson in the terrible truth of military technology. The moment a weapon becomes too powerful, too uncontrollable, and too easily replicated, it ceases to be an asset and becomes a profound strategic liability that must be hidden away, even from history itself. The story of Starhammer thus transitioned from one of technological triumph to one of deep, enduring strategic paranoia, buried under layers of state secrecy, waiting for the day the fear of the enemy would finally outweigh the terror of its own power. By the mid-1980s, Project Starhammer, or System 712, as it was known in its most restrictive technical memos, had transcended its origins as a theoretical physics experiment. It was no longer a research concept, it was a hardened, field-ready instrument of war, waiting for the political fuse to ignite. The Soviet threat, though tempered by the early days of Gorbachev's reforms, remained a colossal and immediate military reality. NATO strategists still operated under the cold assumption that they were outnumbered, outgunned, and outmassed in the critical Central European theater. Starhammer, the silent electronic killer, represented their only chance to reverse the conventional equation without triggering the nuclear tripwire. The Army's goal, spearheaded by the now fanatical proponents within the force's command, was to move the weapon from the test bench to the front line. They had a physical, working prototype, the Mobile Non-Kinetic Area Denial Unit (MNADU), a compact, ruggedized EMP emitter. This final operational unit, though still immense, was towable by a standard M9395 truck and designed to be rapidly deployed. It was a massive, drum-shaped steel container housing the self-destructing capacitor bank and the complex copper flux coil, protected by layers of ceramic insulation. The operational plan was codenamed the Iron Hand Strategy, a testament to its intended decisiveness. It called for the MNADU units to be pre-positioned and carefully hidden along the primary NATO defensive lines, the expected rupture points just west of the inner German border, particularly within the deep forests and rolling terrain leading into the Fulda Gap. The staging, elite, highly vetted teams from the U.S. Army's 11th Armored Cavalry Regiment, reinforced by specialized engineers, were trained in the covert deployment and remote activation of the units. The scenario: if Soviet tanks crossed the border in force, the teams would detonate the units in carefully staggered sequences. The objective was the simultaneous, mass electronic failure across the entire spearhead of the enemy's advance. The theoretical result was breathtaking. Thousands of Soviet main battle tanks, T-72s, T-80s armored personnel carriers, self-propelled artillery, and command vehicles would have their engines instantly vaporized, their radios reduced to static, their targeting computers turned into useless blocks of glass and metal. The entire advance would be rendered blind, immobile, and deaf, a perfect, nonviolent coup de grace delivered by an invisible hand. The subsequent NATO counterattack, facing only inert metal targets, would be a cleanup operation rather than a desperate, bloody defense. This deployment was within weeks of execution. The MNADU units were being loaded onto transport planes. The teams were in final readiness posture. Starhammer was no longer a secret project, it was a loaded gun pointed directly at the heart of the Soviet military doctrine. But the final hurdle, the insistence by the scientific community that one last, large-scale, operational field trial be conducted, proved to be the ultimate undoing of the entire program. The generals needed assurance, they received a terrifying revelation. The final field trial, conducted in a sparsely populated but electronically connected region of the southwestern United States, was designed to test the weapon's interaction with a realistic, complex electronic environment. Unlike previous tests that used isolated, dummy infrastructure, this trial was done near a major, if secondary, communications hub. The location was chosen specifically for its long-range power and communication lines, allowing the scientists to measure the outer limits of the induced current surge. The detonation of the MNADU prototype was technically perfect. The explosive charge fired precisely, the flux was compressed flawlessly, and the resultant electromagnetic pulse was the cleanest, most powerful ever generated without a nuclear device. The weapon worked too well. The test had predicted an effective electronic damage radius of 5 kilometers for heavily shielded military systems and perhaps 8 kilometers for standard civilian infrastructure. The reality was catastrophic. 14-kilometer blackout zone. The sheer intensity of the pulse induced massive transient currents in the power grid that spanned an unbelievable 14-kilometer test zone, cascading far beyond the most pessimistic predictions. The power lines, acting like giant receiving antennae, absorbed the pulse and instantly surged, tripping circuit breakers and causing transformers to explode in a chain reaction that silenced the grid. Critical infrastructure failure. It didn't just disable the test equipment, it shut down every unhardened electronics system connected to that regional power and communication grid. The local hospital. Emergency generators thankfully kicked in, but the initial surge instantly fried non-essential systems, including administrative computers and sophisticated diagnostic imaging equipment. Air traffic control. A small, regional airport's communication tower, linked to the general communication lines, went silent for 47 agonizing minutes until backup systems could be manually rerouted. Civilian communications. Hundreds of miles of telephone lines, both above and below ground, were rendered useless, forcing a massive, prolonged repair operation that was impossible to attribute to anything natural. The collateral damage was no longer a theoretical risk, it was a documented reality. The invisible hammer was far less discriminate than a nuclear blast. While a tactical nuclear weapon would create a smaller, localized zone of total destruction and fallout, Starhammer created a massive zone of electronic paralysis that respected no borders and recognized no difference between a tank and a life support system. For the Pentagon planners, particularly the political and legal advisors, this was the line in the sand. The risk had become politically, legally, and ethically indefensible. The calculus was simple and chilling. Deploying Starhammer meant winning the battle but losing the political war. It meant guaranteeing electronic chaos, potentially crippling the very civilian and logistical infrastructure NATO needed to sustain its own defense. The inevitable public revelation, even after the fact, that the US had deployed a weapon that could silently and instantly disable hospitals and air traffic control over Allied territory was a non-starter. It would break the alliance, destroy NATO's credibility, and unleash global panic over the proliferation of this new, terrifying form of warfare. The decision was swift, decisive, and conducted in absolute secrecy. The program was quietly dismantled. The directive was issued. Starhammer was to be excised from existence. The decommissioning of Project Starhammer was a masterpiece of Cold War-era bureaucratic denial, an effort to not just shut down a program but to rewrite its history. The operation to eliminate all traces of the MNA-DO was codenamed Operation Ghostlight. For decades, the official stance of the U.S. government, whenever queried by journalists or persistent researchers, has been unwavering. The concept of a non-nuclear, battlefield-ready EMP emitter was deemed merely theoretical research, a concept that proved technically infeasible due to power limitations. The physical remnants were dealt with violently and systematically. Components destroyed. The surviving prototype units were hauled to a remote, sealed facility. The immense copper coils were violently dismantled and melted down into ingots for unrelated defense industry projects.